अरे यार ये गलत स्क्रीन में क्यों जा रहा है? हाँ सही स्क्रीन में आ गया। तो देखो प्रिंसिपल कंपोनेंट एनालिसिस के लिए अपन को क्या क्या जानना जरूरी है, लेट मी फर्स्ट टेल यू दोस थिंग्स, है ना। First thing that you need to know is covariance matrix. Actually even before that, one thing that you need to do is how to center a data. Center, this is a verb in here, center a data set. Next thing you need to know is covariance matrix. Other thing you need to know is how to find Eigen value, and from that you need to know how to find Eigen vector. After which what you do is you transform the data. You need to know that this is everything that I will teach today, है ना? Transform the data, identify a principal component, these two are like kind of interchangeable basically, है ना? You can do either one first or after that, it doesn't really matter as much. And finally to transform data in data, let's just do, to transform data with the principal component. Okay, so this is the whole principal component analysis ka algorithm. Okay, let's look into a data. Let's see, let me make a matrix A, which is say something like 3, 5, 7, 9, 11, 12, 15, and that is x-axis for us, and the y-axis will be something like 5, 8, 9, 8, 10, 15, 20. So these are, this is like x-axis point and this is y-axis point, right? Now let's quickly first understand what does principal component do. So principal component analysis, what does it do? So PCA is used to lower the dimension of our data. How it is done? By maximizing information in lower axis. Okay. So these are the two things that you need to know about principal component analysis. Basically what happens is, if you have a two-dimensional data, there are like points in two-dimension data. What we do is we convert it into a single dimension data. Somehow we have to project these points down into single dimension. So these will become our points. But what happens is you have to follow a proper procedure, which is PCA. You give this data into PCA and you get this output, 2D to 1D. If it is 3D, you can get it down to 2D. Or like if you do multiple of these, you can get it down even lower to 1D. Depends on what dimension you need your data in. So currently we have
सर हम यूँ मान सकते हैं कि कोई सपोज 10 फीचर स्पेस है और पीसी क्या काम करता है, उन वेक्टर्स उन फीचर्स को हटाता है जो रेलेवेंट नहीं है, ऐसा मान सकते हैं?
Actually it's not that it's not relevant. What happens is primarily,
यानी कि वो उनके एक्यूरेसी स्कोर में हेल्प नहीं कर रहा. सपोज 10 कॉलम है, उनका एक्यूरेसी स्कोर आ रहा है 94%, हमने 3 कॉलम हटाए, अब उसका एक्यूरेसी स्कोर बढ़ गया 2% और बढ़ गया, सपोज 98 हो गया. हाँ, ओवरफिटिंग नहीं हो रहा है, पर इसी को पीसीए बोलते हैं.
Actually PCA is primarily is like projection of data points from higher dimension to lower dimension.
हाँ
Because imagine if you have 700 dimensions,
हाँ हाँ, तो
है ना?
सर वही हुआ ना सर, 10 वो 10 फीचर स्पेस थे, अब वो 7 बच गए हैं, तो
हाँ,
डायमेंशंस तो कम ही हुई है,
yeah.
मतलब अगर जैसे आप कह रहे हो.
Yeah, but the aim is different. See, aim is not increasing the accuracy or anything, but the aim is कि ये 700 dimensions को how do we project it to like something where we can actually look at it, है ना? How do we?
तो इंडस्ट्री में क्या यूज केस बनेगा इसका, हम क्यों पीसी यूज कर रहे हैं?
एक सेकंड बता रहा है. How do we project these dimensions in visually, है ना? In 2D or 3D, in 2D or 3D. See, the reason you want to use principal component analysis is primarily think of it like you want to see कि कौन सा feature, which feature, so I'll write that, which feature matters the most, so that you can focus on that feature. अरे एक second, so that you can focus on that specific feature. So primarily that is the aim for PCA. You're trying to find out key if I were to make this. So if you have trained a model, see, if this is a model M1 and it is quite complex, and the reason for complexity is what? Like high dimension. So if the reason for this complexity is high dimension, with PCA you can simplify this model in lower. Oh shit, phone call. Sorry. So you can transform this model into something with like less features. So M2 less complex and less features. Which means lower, which is because of lower dimensions. This is what it is. This is what PCA does. Does that make sense? Like, kind of lowers the complexity of your model. Not by changing the model, by the way, directly, but by changing the data it is training on. Give me a second, by the way. Give me a second. Hello. Okay, I'm back. So, so that makes sense, right? This one. 700 dimension. How do we create it? Okay, हाँ ठीक. So primarily, let's look at our data यहाँ पे. Now we can like get back to our problem. This is our data. Can I select this? Also this? No, not like that at least. Yeah, I'll copy that and I'll paste it over here. So so we can actually use it. Okay, so first of all, what we need to do is we need to turn this into centered data. So from A, we need to convert this into A centered. How do we do that? We find X bar and Y bar, basically mean of this column and mean of this column. So you will have, let's see, X bar equals to 3 plus 5 plus 7 plus 9 plus 11 plus 12 plus 15. There's 1, 2, 3, 4, 5, 6, 7 points. So divide by 7. And similarly, Y bar will be equal to 5 plus 8 plus 9 plus 8 plus 10 plus 15 plus 20 divided by 7. Same number of points, right? So can somebody calculate this quickly? 3 and 5, 8 and 7, 15 plus 9, 24, 35, 47 and 50, 62. 62 by 7. This is 62 by 7. And what would that be? Anyone? 8 point something, I guess. I don't know. Let's open a calculator. 62 divided by 7. That comes out to be 8.85. So that is equals to 8.85. That is x bar. And y bar is going to be 5 plus 8 is going to be 13, 22, 30, 40, 55.
10.71 आएगा सर.
10.71. पक्का ना? Okay, so this is like y bar and x bar for us. Now, how do we center it? With these, all we have to do is x minus x bar and y minus y bar. So let's start doing that. This was 8.85. Okay, how do I should be able to make this smaller. Yeah, I can make it smaller just by doing this. Yeah, and this as well, I guess. I'll put it. Oh, there we go. I guess it was hanging up a little. So 8.85. Let's make A centered. This gets transformed into A centered equals to 3 minus 8.85. So calculator. 3 minus 8.85. That is minus 5.85. Minus 5.85. 5 minus 8.85. 5 minus 8.85 minus 3.85. 7 minus 8.85. Can somebody help me with this? Like, you could do it like much quicker. Or should I just open Excel, I guess? Let's do that. 3579. I'll just put it like this. So 3579 11 12 15 equals to A minus 8.85, right? So we have these values that we can use. I'll just put it on the next screen and write it down here. So that is minus 1.85, then 0.15, 2.15, 3.15, and 6.15. Those are the points. And for y, we will have 5, 8, 9, 8, 10, 15. So 5, 8, 9, 8, 10, 15, 20. And the thing that we are subtracting this time is 10.71. So that is 5.75 minus 5.71, then minus 2.71, then minus 1.71, then minus 2.71 again, because that's 8 again, minus 0.71, 4.29, and 9.29. So this is our matrix. This is our like centered matrix. Now from this, what we have to find is there is a formula that you have to remember, and that is going to be covariance matrix. Now this point is done, like centered part is done. So let's see in our algorithm how to center the data, that is done. Now we have to find the covariance matrix. So how do we find a covariance matrix? There is a formula for that, which is covariance x comma y equals to 1 by n minus 1 sigma xi. This I goes like from 0 to n or 1 to n. I don't know, whatever. You can like fix it if you know about it. X minus x bar multiplied by y minus y bar. So this is the formula. So what happens is, what if you have covariance of x and x? Covariance of x comma x. This formula changes slightly into 1 by n minus 1 sigma I equals to 0 up to n. And what happens is, this is also x, this is also x. So xi minus x bar and then you multiply it by xi minus x bar again, which is basically equal to xi minus x bar square. That is what you get. So how do we make covariance matrix? I mean, this is like just calculating one point in a matrix, but how do we actually get it? So the way you get it is you create a table. You have two features. You make xy and xy like this. The top left is going to be xx. The top right is going to be xy. The bottom left is going to be yx, and the bottom right is going to be yy. Now the thing is, if you multiply, and basically what are you looking at? Like this x minus, I mean yi and xi minus x bar and y bar is basically we just calculated it like over here. So this x minus x bar is like this one, and y minus y bar is this one. That is what is happening. So I'll just write it x I minus x bar, and this one is yi minus y bar. That is what is happening here. So this matrix that we've just calculated, that is useful for us for this part. So basically what is going to happen is xi minus x bar multiplied by yi minus y bar will be the covariance. So multiply this point with this point, and then this point with this point, and then this point. So you multiply each one, and then you add them together. That is what's happening. If it is xx, then what you do is you multiply this column with itself, and then you just take that. You take a sum of it, nothing else. So that is a like xy and covariance matrix there. Let me remove these extra arrows. There we go. So yeah, let's start with that. So covariance, so let's find first xx, which is basically we multiply this by itself. So let me, oh, I will have to write this down again. So let me like do it on Excel. I'll just quickly do it on Excel actually. This is going to be 3, 5, 7, 9, 11, 12, 15. That's because I deleted it. And what was it? 8.85, right? Yeah. So this is going to be equals to this minus 8.85. So this is x bar, and I mean that is x and that is y. And what we do is, let's insert a column here. Like let's write it. This is x, this is x minus x bar, this is y, this is y minus y bar. So now we will have xx. Sorry, oh, this is x. Shit, x bar is here. X minus x bar. That one is y. Y minus y bar. Making small mistakes. This you can do with calculator, by the way, in exam. So xx is going to be this multiplied by this. So let's just do equals to this multiplied by this. That is the square of that. And we basically also need the sum. So we'll do equals to sum. That is what we need. And xy is going to be just multiplication of this multiplied by this. And if you multiply this with, sorry, if you multiply this with this, that is xy. And if you do this multiplied by this, that is yx. So this point, xy and yx are going to be the same points. There will be no difference between these two. So that is xy, and then there is yy, which is just a square of this one. So yy, this multiplied by this. So these are, so I also, let's make sum of this. Sum equals to sum. There we go. So these are three values that we have. I'll just write those down. So covariance matrix equals to, I'll also write down like xx and xy and yy. Xx was 104.8, xy is 115.7, and yy is 155.4. 155.4. So covariance matrix is going to be 104.8, 115.7, 115.7, and 155.4. So that is the matrix, covariance matrix that we have. This is important. So you just have to apply it into this formula. Basically, just square this, add this, multiply this by this, add those together, and square this and add those together. That is what you will have. Does that make sense, by the way? This one so far? Any doubts in this? Okay, no doubts for Mohit. Anybody else? थोड़ा तो डाउट होगा किसी चीज में कि प्रोसेस पूरी समझ में आ रही है. Okay, I think process पूरी समझ में आ रही है. Okay, so we are done with making covariance matrix. The important part that you have to remember about covariance matrix is this formula, first of all, this and this variant of that, and then you also need to remember how to make these points. So basically just, this point is like this point over here. You calculate these together like COV that is given like that, COV given like that, and COV given like that. Also, COV yx is the same as this one. So basically equal to that because we are multiplying those two together. So that's that second step done. The third step is finding the Eigen value. So so how many of you already know how to find Eigen value and Eigen vector? Eigen value, whatever you want to call it. Okay, so I'll teach that, I guess. Yes, I'll copy this matrix, copy that, paste that over there, and that goes over there. I'll make it a little smaller. There we go. So how do we do that? This is matrix. Let's just call it A. Again, now we'll call it B actually, because A is the data set. So that is B. So how do we find it? That would be B minus lambda I, and you have to find the determinant of that. Determinant, this gives you Eigen value. So let's do it. I is the identity matrix. Basically, a 2 by 2 identity matrix is diagonals with 1. Or if it was 3 by 3, then it would have been like 3 ones with zeros everywhere else. These are identity matrices. So what we do is I multiplied by lambda. So I lambda is equals to lambda multiplied by 1100, and that is equals to lambda 0 0. This is the matrix. Now we have to do B minus I lambda. So that is going to be like I can paste it again. Oh shit. Let me, yeah, there we go. So over there, actually I can move this closer, I guess, to that. Yeah, and that would be minus I lambda, which is this matrix. So lambda 0 0, which is equals to 104.8 minus lambda 115.7 115.7 155.4 minus lambda. This is the new matrix, and we have to find the determinant of that. So determinant of 104.8 minus lambda 115.7, and this is also a matrix, so I'll have to make that 115.7 155.4 minus lambda. I will make this like this, and that, and equals to 104.8 minus lambda, which is basically this point multiplied by this point. So if this was A, this is B, this is C, this is D. So A, the determinant is A D minus B C. Multiplication of these two and these two. You subtract those. So 104.8 minus lambda multiplied by 155.4 minus lambda, and minus 115.7 multiplied by 115.7, which is the square of this. So let's take out our calculators and solve this. So first of all, 115.115.7 multiplied by 115.7. So that is 13,000. What? Okay, that's a big number, 13,386. So let's make it equal to, I'll just write determinant equals to minus 13,000 at the end, minus 13,386.5 approximately. And this one has to be solved like this. So there will be minus 104 lambda, 104.8 lambda, 0.8 lambda, and also minus 155.4 lambda, minus 155.4 lambda, that. And then there is also going to be lambda square, and then there is also going to be multiplication of these two numbers, which is going to be positive, 104 into 155.4. So 104.8 multiplied by 155.4. So that is going to be 16,285 plus 16,285.9. So we solve this by subtracting these two, I guess. So let's just write it. Lambda square 16,285.9 to minus 13,386.5, 13,386.5. That comes out to be 2899.42. So that is plus 2899.42. I think just rounding it up to like 2,900 might be a better idea to do this. And then there is 104.8 and 155.4. So we have to add those. 155.4 plus 104.8, 104.8. That is 260.2 minus 260.2 lambda. So this is our equation. Just going to round it out because that's going to like make our life a little simpler, I think, not too sure. So lambda square plus 2,900 minus 260 lambda. So this is A, this is B, this is C. So now we can use our tool that we opened earlier, which is quadratic calculator. So let's use that one. A is 1, B is 2, minus 260 and 2,900. So this is 1 minus 260 and 2,900. So let's calculate that. Please don't be, yeah, it's not, okay. Whew. So 248.322 and 11.67. So 11.67 and 248.322. So our lambda 1, actually that is just root 1 equals to, shit, I forgot the numbers. Like my brain isn't working today. 248.322 and root 2 is equals to 11.67. So these are our two roots, right? To this, two values of lambda. Make sense so far? These are actually what's called Eigen value. Or, you can definitely like write it as lambda 1, lambda 2. Doesn't really matter as much. Lambda 1 and lambda 2. Make sense so far? हाँ क्लास ले रहा नहीं. Okay. Question from outside the room. Anyway, so this is Eigen values. Now that means we are done with one more step. That's this one. Now we have to find the Eigen vector. So for Eigen vector, what we have to do is we have to take this matrix over here. So let's copy this matrix and paste it over here. Oh, not over there, please. I'll bring it further down over here. Actually, a bit more over here. So now let's do Eigen vector. So for Eigen Vector, we use this value of lambda 1 and lambda 2. What you do is, first you create, let's make for lambda 1. So we take the value of lambda 1 and we apply it in both of these. Like this lambda and this lambda, we just replace it with that. So what we get over here, lambda 1 equals to 248.32. And what we do is, we create a matrix 104.8 minus 248.32, 115.7, 115.7, and 155.4 minus 248.32. So this is only taking lambda 1, not taking lambda 2 yet. We will do lambda 2 after this. So 104.8 doesn't, like, somebody do this quick. I mean, 104.8 minus 248.32, that is minus 143.5. So that is minus 143.52. And this is going to be 115.7. This is going to be 115.7. This one is going to be, let me go to the calculator. So 115.4 minus 248.32. That is going to be minus 132.92. Minus 132.92. So this is our matrix for now. Now what do we do with this matrix? We take this matrix. Let me copy this. This is like equal to, and what we do now is multiply it with x, y. So how do we do that? And make it equal to 0, and make it equal to 0. So how do we do that? We paste it. Not in the question paper, I mean answer sheet, not possible, but paste it. Oh shit, I keep on like clicking at weird places. So yeah, what we do is we multiply it by xy, and you don't really have to do this, by the way. Like, you don't actually have to do this, and we just make it equal to 0. Dot product. What this actually means is, we take this as x and we take this as y, and then we create an equation and we solve it. So that is like minus 143.52x plus 115.7y equals to 0. That is our first equation. And the second equation is going to be 115.7x minus 132.92 y equals to 0. That is our second equation. Now look at this, that both of these are equal to 0. So it really doesn't matter which equation you take to solve this. And if you actually try to solve this by elimination, what will happen is, like, you will end up like reducing one of these to 0. So actually, to solve this, you take either one of the equation, preferably the first equation. We'll just take that one every single time. So I'll take that first equation, and what I'll do is, from equation 1, we have minus 143.52x equals to, we take this on the other side, which is minus 115.7y. So we make it plus on both sides. This is the coefficient of x and this is the coefficient of y, and these two are versions of each other, so there is no point in like trying to eliminate it. What we do is, we just take this coefficient and this coefficient, and we make a vector out of it. So vector 0 is equals to 143.52 and 115.7. So this is the first eigenvector. That is the first eigenvector. Makes sense so far? Any doubts in that? Okay, good, very good. All right, so the next part is going to be, we take other, yeah, Aditya. Yeah, the other eigenvector. So the other eigenvector is, other eigenvalue is 11.67. So we take that. So we write for lambda 2 equals to 11.67. We do the same mathematics over here. We will copy this equation, I mean this matrix, copy, paste, there we go. So with that we have 104.8 minus 11.67 and 155.4 minus 11.67 and 115.7, 115.7. Can somebody quickly tell me these values minus करके इनको? 115.7, 115.7. Calculator खोलना ही पड़ेगा मुझे. So let's do this. That's going to be 104.8 minus 11.67. That is 93.13. 93.13. And this one is going to be 155.4 minus 11.67. So that is 143.73. 143.73. Now what do we have to do? We have to repeat the same process, the one that we did over here. We multiply it by xy. So we just take this, copy, and we paste it over here, and we will make it a little smaller. Multiply it by xy, dot product equals to 0. Now similarly we will 93.13 x plus 115.7 y equals to 0. That is our equation 1. 115.7 the x and plus 143.73 y equals to 0. That is our equation 2. Taking just the first equation, we will get 93.13 x equals to minus 115.7 y. We take these coefficients and we create the vector 1 equals to 93.13 and minus 115.7. Okay, so this is the other eigenvector. Process clear so far? Any doubts? So basically it's up to this point. Any doubts yet? Okay, good, no doubts. Now see, you have two options. First of all, we can use both of these. I mean, where's the other vector? This is the first vector and this is the other vector. Okay, so we take v0 and we can create a transform. There is a matrix called W. It's a transformation matrix, and there is a full form for W. I have completely forgotten what it is. It is basically vector 0 on the left hand side and vector 1 on the right hand side, and you will basically write it like this: W equals to 93.13 and minus 115.7 on this side, and on this side it will be the other vector, which is equal to 143.52, 143.52 and 115.7. So 115.7. So now I'm going to take this like here, and I'll have to move it down a little, I guess, because I forgot to write the heading: transformation of data. Okay, and this is the transformation matrix. Okay, wow, heading, but yeah, let's see. So there are two things. First of all, writing these next to each other, you can kind of tell that vector 0 has a lot more, like the values are higher. It has more information compared to vector 1. Vector 0, vector 1, right? So this has more information. This has less information. And like one of these is like a negative. So first of all, we can already tell that V0 is the principal component. V0 is the, because it has more information, is the principal component. But primarily what is going to happen is that you need to kind of understand that you have to choose either V0 and V1 at the end of principal component analysis. And the better way to do that is not choosing it from just looking at the numbers right here. This is why I said that these two processes are like interchangeable. Most people, what they do is they will just find the bigger vector and they will just identify the principal component using that. But that in very specific cases will not work. Like those cases are not as many as like how many times it will work. So say 5% or 2% of the times that might not work. So what you do is you take your main data matrix A, which is like all the way at the top. This is the A matrix over here, and you multiply it with the transformation matrix. So you take a dot product with transformation matrix. So you will get a transformed matrix, transformed data points. All right, makes sense. So what will happen is like one of these two. So eventually what will happen is it will change the values of A, and it will still be in the same dimension. It won't change the dimension of the data, but this will give out a matrix that is same dimension output. But what will happen is the values will change. And then you have to figure out which column has more information. Depending on that, if the left column has more information, you take V0. If the right one has more information, you take V1. So either way, like you can decide over here, and people usually even do worse than that, and they will eventually just pick up the first vector and they will just do the principal component analysis using that. So what we are going to do here is we are going to multiply these two matrices. So let's quickly go to another tool that we opened earlier, because I don't want to go through the process. Yeah. Is there a doubt?
No.
Okay. So number of rows in this is 7, matrix 1, and columns are 2. Number of rows in this is 2, and this is 2 as well. Set matrices. So let's we'll have to give values of this. So this is going to be 3, 5, 5, 8, 7, 9, 9, 8, 11, 10, 12, 15, 15, 20. And over here, where is it? Where is our transform? This one. So 143.52, 93.13, 115.7, minus 115.7. There we go. Calculate. So this is the this is the final matrix that we have. Let's write it down. Should we even write it down? I don't understand if it is like required. So having A dot W, let's copy A first, like so nobody gets confused from these notes. Where is A? There. So I copied that and I'll paste it over here. A is already written, so I'll take oh, I can't select that alone. Delete that, and I'll move it over here. And W is this. Copy, paste. So that's A and the transformation matrix, and we have to find A dot W. So A dot W equals to, I'll just make a note here using online calculator. For dot product. And so basically I'm skipping that step kind of. So I'll put it, oh shit, it went on to the other monitor. Yeah, over here. So this matrix will come out to be the transformed matrix 1009.06, 1643.2, 2045.94, 2217.28, 2735.72, 3457.74, 4466.8. And on this side, minus 299.11, minus 459.95, 389.39. This one is going to be minus 87.43, minus 132.57, minus 617.94, minus 917.05. So that's that. Now, how can you figure out which one has more information? Basically, I can tell that the lowest point here is 1000, highest point is 4000, but these ones are like quite close. There is definitely more information in this column, which is still still kind of same. Like we are still choosing vector 0, and in this case, it works perfectly fine that you can choose it directly from the transformation matrix. That this one is better, this one is bigger, has more information. So this column has more information. Now we have vector 0 as our choice, therefore we'll just write it. Therefore vector 0 is the principal component that we require. All right. So with this, what we have done is two parts. We have transformed the data, and we have also identified the principal component. So now all you have to do is to transform the data with principal component. Now this one is easy. We just take this matrix A and copy that. So now last step, transform data with the principal component. So for this, sorry, we paste that over there, and all we have to do now is multiply it with our vector, which is v0, dot product with v0, which is equal to, well, I have to like paste it again, but this time I can delete this, and I can delete this, and I can move this over to over here. So 7 is to 2. But how do you multiply that? Like row column, acha, row column. Okay, yes, that's perfectly fine. So we take these two, copy, and we paste it over here. So dot product of these two, and we will get a matrix. And okay, I'm like making a mistake here. My bad. This is not what you do. Like this is, sorry about that. I completely confused it with the last step. So let me remove this. What you are supposed to do is you're supposed to pick up each point, which is, so for example, this is point 1, this is point 2, this is point 3, this is point 4, this is point 5, this is point 6, and this is point 7. Basically, you take 1 point. So for point 1, we have to do P1 multiply now dot product with vector 0, because we chose vector 0 as a principal component. So which means 3, 5 as a matrix multiplied by V0, which is, what was it? 143.52, 143.52, and 115.7. I think that's the one, yeah, 115.7. So what happens is you get 3 multiplied by 143.52 plus 5 multiplied by 115.7. So that is equals to that, that is equals to that. And can somebody do this? 3 multiplied by 143.52, that is equals to 430.5. So this is equals to 430.5 plus 5 into 115.7. 5 multiplied by 115.7, that is 578.5. It is 578.5. That is equal to this plus 430.5, 1009. So that is equals to 1009. So finally, you are starting to create a matrix. So this is A transformed. Now I'll just write it A as A principal component equals to, this is the first data point, 1009, and this becomes a single dimension matrix, like one single dimension. So from 2 dimension, this is 2D, we went into 1D, and that is what principal component analysis does. So with point 2, so similarly for point 2, we have 5 into so basically 5 8 and 143.52, 115.7, dot product of these two. And can we use the tool for this? So this is 1 row 2 column, 2 row 1 column. So where is it? Go back. 1 row 2 column, 2 row 1 column. Yeah, set matrices. So that is going to be, oh yeah, this should be doable now. So 5 8 5, oh, what am I doing? This is 5, that is 8. This one's going to be, oh, I need to see the matrix. 143.52, 115.7. So calculate, and we have 1643.2. So this one goes over here, 1643.2. Similarly with the next point, which is going to be 7 and 9. We, oh, what? Not allowing. I'll just refresh this. Set matrices. That is going to be 7 and 9. This one is going to be 143.52 and 115.7. Calculate. We get another number, 2045.94. 2045.94. So there is 4 more to do. Can you guys like do that? Anyone? Please. 115.7 and 9 and 8. 9 and 8. 2217.28. One 143.52 and 115.7, and this one was 11 and 10. 1 2 3 4 and fifth point here. Calculate. 2735.72. 2735.72. 1 2 3 4 5. So 2 more. So 1215. 1215. 143.52 and 115.7. 3457.74. 3457.74. And finally, last point, 1520 with 143.52 and 115.7. Calculate 4466.8. Wait a minute. Okay. This is very sad, by the way. Same thing. I just realized. Okay, so these are the same values. So if you calculated that matrix, then yeah, you had the same thing. So this is the this is what principal component analysis is, by the way. That's about it. Like this is your final result. Any doubts? I'm tired using the calculator. Hmm?
You said that V0 is principal just because it is showing more content, right?
Yeah. Just because this is like much higher,
Range.
you can figure out that this is higher, like higher values, and then from like multiplying with the transformation matrix, you're getting higher values as well. Over here, more information equals better.
So we are saying like the range is high, or we are saying the values are high. Like which one?
The range is high, the variance is high, I guess.
Okay, minimum to maximum like
Yeah,
value.
minimum to maximum.
Okay.
And yeah, I guess positive. I mean, in few of the examples, what happens is like, I mean, this is like I just created a random matrix, right? Like, right, hey, this is a random matrix. But usually, like, you will find out that most of the times, one of this column will just completely turn out to be zero in like real life example. So, like, that's just if it doesn't, then you take the larger values. That's it.
More towards positive, right?
Yeah, yeah.
Okay.
Yeah. So I mean, I guess we kind of solve it at this point. But yeah, it's kind of the same result if you're going to do it point by point. Makes sense? Or like any doubts? This is literally like the whole principal component analysis. If it were to come in the question paper, you'll be like solving it in like this much, pretty much up to this point, I guess. So yeah, that's it for today's class. We'll do the other methods tomorrow. Like I mean, it's not like most of these methods are long or short. It's just that if you're using the correct tool, if you're allowed to use the correct tool. For example, if you're allowed to use Python, then you can do this like extremely fast with dot products and everything. So yeah, right.
Radhika, I take a question.
I'm
Class now.
I have no idea. I haven't seen the video, but this is what principal component analysis is like. This is what I know about. And इसके अलावा I'll also keep on getting that phone call. Anyway, so oh my god, still getting the phone call. Anyway, let's end the class here for today. And
आशुतोष भाई एक बार वो एसएनए का असाइनमेंट 5 मिनट 10 मिनट अगर आप दे सको तो
okay, then give me like a 10-minute break. Then
श्योर
I'll
श्योर श्योर
quickly tell you.
श्योर श्योर
Yeah, I'll have to like pick this call. Like this
ओके
person
ओके
will
गो
not
अहेड
stop calling me.
श्योर श्योर
Okay,
Bye bye. I'm leaving up.
all right.
StatQuest is the best. If you don't think so, then we have different opinions. Hello, I'm Josh
Kanishka,
Starmer.
you are late.
Welcome to Step.
तो ये ग्रुप पे अभी क्यों मैसेज डाला है
ये हर्षल है.
अभी आई एम लाइक यार पीसीए मतलब मेरे को मैंने पूछा था कि हो गया क्या सेशन तो
हाँ.
भावेश वाज लाइक कि हाँ मैंने तो छोड़ दिया बीच में हो गया तो मैं कहा हो गया होगा अभी मैंने देखा 11:30 पे मैसेज डाला है मैं कहा अभी भी चल रहा है
मैंने इसलिए डाला भाई मैसेज कि कोई डाउट ही नहीं पूछ रहा ऑलरेडी अपन 6 लोग हैं उसमें से 3 स्क्रीन तो आशुतोष सर की है तो भाई डाउट नहीं पूछेंगे तो फिर बाद में लोगों को डाउट गिरेंगे फिर ऐसा
एक्चुअली पीसीए का ये भी तो है ना, पीसीए अब तीसरी चौथी बार हो रहा है तो अब क्लियर हो ही गया है.
बात
वो
है
तो है
हाँ
क्योंकि वो मैथ्स में पहले हुआ था.
और
ठीक है,
हाँ हाँ
ऐसा है.
ठीक है फिर तो हो गया ना अभी
हाँ,
चलो
बट अभी बस एसएनए के लिए मैंने बोला है कि एसएनए के एक बार असाइनमेंट
अच्छा
में
अभी वो
एक दो डाउट
करवाएंगे
है. हाँ, वो थोड़ा एक दो डाउट है मेरे को.
तो मतलब स्टार्ट से करवाएंगे या ऐसे ही डाउट्स क्लियर करेंगे
अगर या वो ऐसे तो मेरे को तो डाउट ही क्लियर करवाने हैं. अगर तुम लोगों को स्टार्ट से चाहिए तो वो करवा देंगे, वैसे कोई बात दिक्कत नहीं है.
अच्छा ठीक है फिर हर्षल बता दे मेरे को बता देना फिर अगर वो स्टार्ट से करवाते होंगे तो
चलेगा मैं
मैं ज्वाइन
वैसे
कर लूंगी
रिकॉर्डिंग कंटिन्यू ही रख रहा हूँ तो
हाँ
कुछ भी डाउट हो गई तो फिर सॉल्व हो जाएगी ये रिकॉर्डिंग में ही
चल
अरे
ठीक
ये वाली रिकॉर्डिंग भी होगी क्या हमारी बातों की?
हाँ होने दो अभी
अरे
क्या वैसे तो अपना ही क्लास देखने वाला है बाकी कोई नहीं
सोचो यूट्यूब पे अगर टीचर देख रहे हैं इसको, नहीं कहेंगे यार ये लोग क्या कर रहे हैं.
कोई बात नहीं चलने दो वो भी मजे करेंगे
बाद में प्लेजरिज्म लगाएंगे, ये हरकतें करी है इन लोगों ने सब. मास प्लेजरिज्म.
कोई नहीं चलो ठीक है फिर
ठीक है, ओके.
बाय
That quest. Today we're going to be talking about the main ideas behind principal component analysis, and we're going to cover those concepts in 5 minutes. If you want more details than you get here, be sure to check out my other PCA video. Let's say we had some normal cells. Psst! If you're not a biologist, imagine that these could be people, or cars, or cities, or etc. They could be anything. Even though they look the same, we suspect that there are differences. These might be one type of cell, or one type of person, or car, or city, etc. These might be another type of cell. And lastly, these might be a third type of cell. Unfortunately, we can't observe differences from the outside. So we sequence the messenger RNA in each cell to identify which genes are active. This tells us what the cell is doing. Psst. If they were people, we could measure their weight, blood pressure, reading level, etc. Okay, here's the data. Each column shows how much each gene is transcribed in each cell. For now, let's imagine there are only 2 cells. If we just have 2 cells, then we can plot the measurements for each gene. This gene, gene 1, is highly transcribed in cell 1 and lowly transcribed in cell 2. And this gene, gene 9, is lowly transcribed in cell 1 and highly transcribed in cell 2. In general, cell 1 and cell 2 have an inverse correlation. This means that they are probably 2 different types of cells, since they are using different genes. Now let's imagine there are 3 cells. We've already seen how we can plot the first 2 cells to see how closely they are related. Now we can also compare cell 1 to cell 3. Cell 1 and cell 3 are positively correlated, suggesting they are doing similar things. Lastly, we can also compare cell 2 to cell 3. The negative correlation suggests that cell 2 is doing something different from cell 3. Alternatively, we could try to plot all 3 cells at once on a 3-dimensional graph. Cell 1 could be the vertical axis, cell 2 could be the horizontal axis, and cell 3 could be depth. We could then rotate this graph around to see how the cells are related to each other. But what do we do when we have 4 or more cells? Draw tons and tons of 2-cell plots and try to make sense of them all? Or draw some crazy graph that has an axis for each cell and makes our brain explode? No, both of those options are just plain silly. Instead, we draw a principal component analysis, or PCA, plot. A PCA plot converts the correlations, or lack thereof, among the cells into a 2D graph. Cells that are highly correlated cluster together. This cluster of cells are highly correlated with each other. So are these. And so are these. To make the clusters easier to see, we can color code them. Once we've identified the clusters in the PCA plot, we can go back to the original cells and see that they represent 3 different types of cells doing 3 different types of things with their genes. Bam! Here's one last main idea about how to interpret PCA plots. The axes are ranked in order of importance. Differences among the first principal component axis, PC1, are more important than differences along the second principal component axis, PC2. If the plot looked like this, where the distance between these two clusters is about the same as the distance between these two clusters, then these two clusters are more different from each other than these two clusters. Before we go, you should know that PCA is just one way to make sense of this type of data. There are lots of other methods that are variations on this theme of dimension reduction. These methods include heat maps, T-SNE plots, and multiple dimension scaling plots. The good news is that I've got stat quests for all of these, so you can check those out if you want to learn more. Note, if the concept of dimension reduction is freaking you out, check out the original stat quest on PCA. I take it nice and slow so it's clearly explained. Hooray! We've made it to the end of another exciting stat quest. If you like this stat quest and want to see more of them, please subscribe. And if you have any ideas for additional stat quests, well, put them in the comments below. Until next time, quest.
Okay, covariance of all. Okay.
हेलो, वापस आ गया।
वेलकम बैक ब्रो।
तो हाँ यार, इसका भी पीडीएफ तो भेज दूं मैं ग्रुप में पीसीए का। शेयर एक्सपोर्ट, सेव एक्सपोर्ट पीडीएफ, सेव। ओके, एसएनए असाइनमेंट में फिलहाल व्हाट इज द डाउट?
भाई मुझे तो आपने जो कम्युनिटीज में इक्वल टू 2 डाला है ना,
हाँ,
वो क्यों डालने की जरूरत पड़ी हमें? क्योंकि आई थिंक वो तो सारा कुछ अपना इसी ने ही कैलकुलेट करना था। अगर मैं 2 को 3 4 कर देता हूँ उसी हिसाब से वो कम्युनिटीज बना के दे देता है मुझे।
हाँ हाँ
तो आई थिंक वो हमें देना नहीं था, वो इसका काम था एल्गोरिदम का खुद से कैलकुलेट करने का।
ओके।
वहां मेरे को कंफ्यूजन स्टार्ट हो गया, तो मुझे लगा आपने कुछ देखा होगा वगैरह, कुछ समझा होगा,
नहीं
इसलिए आप।
नहीं, मैं I'll tell you what I did primarily इस बार because I had like very little time
हाँ
तो ये सीधे उठा के असाइनमेंट का जितने क्वेश्चन थे मैंने पहले जीपीटी को दिए,
ओके
तो उसके बाद में उसको एक एक करके ना वो करते गए, क्या बोलते हैं कि बेसिकली जो जो इशू आते रहते वो रिजॉल्व करते गए,
ओके
है ना। एंड वंस इट वाज ऑल रिजॉल्व, उसके बाद मैंने पूरा कोड चला के देखा, वॉट एवर द एरर केम उसको मैंने हटाया,
ठीक है।
एंड देन इट वाज डन।
ओके
हाँ,
फिर ठीक है।
बेसिकली द होल प्रोसेस जो है ना कि इट इज, थिंक ऑफ इट एज की इशू क्या है ना कि पहला जो कोड लिखा था जीपीटी ने, दैट इज व्हाट द कोड विल डू इफ यू डोंट गिव इट कम्युनिटीज का साइज, है ना। कम्युनिटी का साइज नहीं दोगे तो वो कंटिन्यूअसली उसको ना डिवाइड करते जाएगा करते जाएगा करते जाएगा अंटिल एवरी सिंगल नोड इज इट्स ओन कम्युनिटी,
यस।
है ना।
हाँ हाँ
तो दैट इज द रीजन व्हाई आई हैव पुट इट एज लाइक कि वो एक नंबर कि कितने कम्युनिटीज में बांटना है उसे,
बांटना है।
है
ओके
ना। तो दैट इज व्हाट इट इज लाइक, अगर मैं उसको 3 कर दूं तो वो 3 कम्युनिटीज, 3 क्लोजेस्ट कम्युनिटीज में बांट
हाँ
देंगे उसे,
बांट देगा,
है
राइट।
ना।
ठीक है ठीक है ठीक है। ओके मैंने कहा इसलिए पूछ रहा था कि मुझे लगा मैं कुछ शायद मिस कर रहा हूँ जो यानी कि आपने नहीं किया। तो ओके ठीक है, तो ये उसका है। तो आज के 2 दिन पड़े थे, अभी तो आराम से बना लेते यार अच्छे से।
अच्छा 2 दिन आगे बढ़ गया है वो।
हाँ नहीं 10 तारीख को करना है ना सब।
ओह माय गॉड, अब क्यों कॉल आ रहा है। मैंने सब भेज दिया है, गिव मी अ सेकंड, मैं मैसेज कर देना इसको। एक्चुअली में क्या है कि वो नेट का, वो यूजीसी नेट होता है ना एग्जाम, तो फ्रेंड ऑफ माइन गिव दिस एग्जाम और वो उसका अभी आंसर की चैलेंज करने का आ रहा है। आई थिंक टुडे इज द लास्ट डे फॉर दैट।
फॉर आपके, अच्छा वो फ्रेंड वाली कहानी, ओके।
हाँ हाँ,
मुझे लगा
और उसके पास पीसी है नहीं तो शी इज लाइक कि भाई तू ही कर दे इसको।
ठीक है
तो एनीवे लाइक ये इसमें द ओनली रीजन दैट लाइक कम्युनिटीज एडिट कि वो पूरे को अलग अलग ना कर दें, नो अदर रीजन,
ठीक है ठीक है
है
ठीक
ना।
है, समझ गया। ठीक है फिर अभी मैं देखता हूँ, फिर मैं इसको थोड़ा वो करके सेट करके करते हैं।
हाँ
ठीक है। हाँ
हाँ,
भाई करते करते करते
ये तो कुछ छोटा सा डाउट बसता है यहाँ पे इसलिए।
ये वाली चीजें रिकॉर्ड नहीं करनी थी।
हाँ।
ओके आई थिंक मोनिका